Okay, teammates, so today we are combining our knowledge from lessons 1 and 2. The only major difference is that we are starting off with unlike denominators. So if I am going to evaluate an expression and I'm going to use a model, so the model we're using is tape diagrams. If I'm going to use a tape diagram to represent a division of fraction problems, I need to make sure that they have the same denominator. When I look here, I see that I have different denominators, so I need to create a common denominator. So I'm going to ask myself, what is the greatest number that both 8 and 4 go into? So another way we think about this is the least common multiple. Okay, so what is the smallest number that both of those numbers go into? And that is 8. So that means the denominator for both of these is going to be 8. I know that 13/8, I'm keeping that same denominator, so it stays 13/8. And then to go from fourths to eighths, I am multiplying by 2. Whatever I do to the denominator, I need to do to the numerator, so this becomes 6/8. So now if I'm going to evaluate this expression using a tape diagram, I know that I am going to look towards my denominator to tell me how many pieces of my tape diagram I need to split it into. So I know that I always start off with one whole, and then the one whole is being split into the amount of the denominator. So I'm going to split this tape diagram into eighths. I split it into eighths by drawing 7 lines. Now that I have eighths here, I know that I'm going to look to the numerator of my dividend, and that is going to tell me how many boxes I shade. Now I'm pausing because I noticed that my numerator is larger than my denominator. Therefore, just one tape diagram is not going to be enough to demonstrate this problem. So I know that I need to draw another tape diagram that I am also going to split into eighths. So again, I'm going to split it into eighths by drawing 7 lines. So now that I have 2 tape diagrams, remembering that one tape diagram represents one whole, meaning that one whole is equal to 8/8 in this example. Now I need to represent my dividend, so what I am starting with, the number that is being divided, and I'm going to represent that on the tape diagram by shading the amount of boxes of the numerator of my dividend, which is 13. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I want to make sure I label it because that is part of the criteria for success for tape diagrams. So that is 13/8. Now I know that a division problem is asking how many equal size groups of our divisor are in our dividend. So with this problem, how many equal size groups of 6/8 are in 13/8? I know that in this tape diagram, one box represents 1/8. So one group is going to have 6 of these boxes. So I'm going to count 6 boxes. I have 1, 2, 3, 4, 5, 6. So that is a group of 6/8. And then I have 1, 2, 3, 4, 5, 6. That is another group of 6/8. So now this is where we need to pay very close attention. I see that I still have one box remaining that is shaded. So that means what's left is one box out of the amount that would be needed to make a group. Many of us have been leaning towards saying that it would be 1/8. However, this is incorrect because it's not 8 boxes that make a group, it is 1, 2, 3, 4, 5, 6 that make a group. So we have one remaining box out of the 6 boxes that would be needed to make another group. So when we write our quotient, sorry, I ran out of room, I have one whole group, a second whole group, so that is where my whole number comes into play, and then I have a remainder of 1/6. So our quotient is 2 and 1/6. And then teammates, we can remember that we can check our quotient by doing a standard algorithm, which is multiplying by the reciprocal, or what we refer to as keep, change, flip. So I'm going to keep my first fraction. I am going to change the operation, and I'm going to flip the second fraction. So now I have a multiplication problem of 13 over 8 times 8 over 6. Since I know that I can cross simplify, and I know that 8 and 8 have the same greatest common factor of 8, so they both reduce to 1. Now I'm just multiplying straight across. 13 times 1 is 13. 1 times 6 is 6. I have a fraction greater than 1, so I need to turn that into a mixed number. 13 divided by 6 is 2. And then there is 1 left over, and I keep the same denominator. So I have 2 and 1/6, which matches what we got using a tape diagram. Okay, so the criteria for success for your exit ticket today is going to be showing not only the tape diagram, but then checking your quotient using this method. So you should be 100% certain when you submit your answer that it is correct, because you found the quotient 2 different ways and the quotients should match.